Okay, so the last part of 3.8 is the percent yield. To calculate the percent yield, you have an actual yield, which is experimentally determined, but for us, doing problems, is given. Okay, so you'll always be given the actual yield, expressed as a percentage of the theoretical yield, which you will be calculating from there. So the amount you should get is the theoretical yield. The amount you really do get is the actual yield. And then it's basically, this is the part, that's the whole times 100. So the formula, and I don't know, I tried redoing this formula, it's still funky. Percent yield is the actual yield divided by theoretical yield times 100. So for an example, if I buy a package of the rolled up cookies, okay, and the package says should make 24 cookies, okay, I burn some, I slice them a little too thick, whatever. I got 19 cookies, and I actually counted in the picture 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's not a cookie. I don't know what that is. Because in all fairness, I just grabbed these two images off of the internet, and I made up the 24. Okay. Percent yield is the 19 cookies that I actually was able to produce for whatever reason. The 24 is what the package said I should be making if I do it all right, times 100. So my percent yield on my cookies is only 79.2. So when I'm doing chemical reactions, it's even worse than that because of the fact that I may have reactions I didn't know about going on. I may drop some of my samples somewhere along the way, whatever it may be. This is a really good yield, actually, okay, for chemistry. All right, so let's do an example of that one. Now, I'm cruel because this example, number 98, has both percent yield, but it also has limiting reactants also, okay? So how do I know that? All right, first of all, a theoretical reaction, or a limiting reactant, before I start the problem, a limiting reactant problem given at least two masses both reactants, or all reactants, I should say. All reactants. Okay? A percent yield problem, I'm given at least two masses. But here's where it's different. Okay? One is a reactant, and one is a product. Okay? So this one has three masses, 1, 2, 3. Okay? But the salicylic acid, which identifies as this, is a reactant. The 10.31 grams of methanol, which is identified as this, is a reactant. And the CH8O3 is a product. And it says, what is the percent yield? So it's a limiting reactant problem because I'm given two masses, which both are reactants, and it's a percent yield problem because I'm given one of the products. Okay? So keep doing that button. Don't mean to. All right. So how do we do this problem? Okay. Well, again, there's some information I'm going to need that is not given to me. Okay. But I do start out with the fact I have 2.50 grams of the C7H6O3. I have 10.31 grams of CH3OH, and I have 1.27 grams of C8H8O3, and they want to know what the percent yield is. I don't think I did this in the last problem. That's a mistake. Information that I'm going to need that I don't actually have in the problem is I'm going to need the molar mass of my C7H6O3. Got it the same way, 7 times the carbon, 12.01, 6 times 1.01, 3 times 16 is 138.13 grams per mole. The molar mass of my CH3OH 1 times carbon, 3 times hydrogen, 1 times oxygen, 1 times hydrogen is 32.05 grams per mole. And the molar mass of C8H8O3 is 152.16 grams per mole. Okay, so since this is a limiting reactant problem, I'll start this the same way as I did the last one. I have 2.50 grams of my C7H6O3. I'm going to divide by the molar mass because I have to be in moles to compare them out. So basically I'm given this, I'm given that, and I need to find the theoretical yield. So I need to find the theoretical yield. Okay, so since I have different compounds, I have to be in moles. So I take this, divide by my 138.13 grams per mole of C7H6O3, C7H6O3, and that gives me 0.01810 moles of C7H6O3. Now to get to the methyl salicate, okay, I use the coefficients again. The coefficient there's 1, so 1 mole of C8H8O3 to 1 mole of what I'm coming from, which is C7H6O3. Gives me, again, the 0.01810 moles of C8H8O3. Okay, I have to do the same thing with the methanol, so I have 10.31 grams of CH3OH. Again, I divide by the molar mass, which is 32.05 grams per mole of CH3OH. And that gives me 0.3217 moles of CH3OH. Again, all the coefficients here are 1, so I have 1 mole. And even if the coefficients are 1, I want you to show me this step, because I'm going to assume that you don't know what you're talking about. 2. I have to kind of wrap that around our room. Oops, C8H8O3. Okay, so which one produces the least amount of C8H8O3? And it is this one. I keep pushing that wrong button. It is this one. So that's the one I'm going to use. Okay, so to find the theoretical yield or the mass, I'm going to take that 0.01810 moles of C8H8O3 times its molar mass of 152.16 grams per mole, and I get 2.574 grams of C8H8O3. So that is the theoretical yield, but that's also the answer to the limiting reactant. But I'm not done yet. So if you still haven't gotten all this written down, I'd pause the video because I'm getting ready to erase something. Okay, so I'm going to go ahead and erase this corner here because I need more room to work. Run out of slides. I don't want to erase everything because that would take it all away. But I want to erase everything here. Okay, so, and I'll change color so that you can see it's different. So the percent yield is the actual over theoretical times 100. Okay, so that's going to be equal to my actual is given is 1.27 divided by the theoretical, which is 2.754 times 100. And I get 46.1%. And that's the final answer to this problem. And that is the end of Chapter 3 and this video.